We're going to look at a few problems with Lesson 2, which is Chapter 5 in your textbook. Just a few problems as examples. Now, as you should know by looking at the text or from past experience, the prime numbers are numbers that are divisible by themselves and 1 only. So the set of prime numbers would include 2, 3, 5, 7, and so on. There are infinitely many primes. One of the things that we want to do is give a prime factorization of a number. That is, we want to break it down into a product of primes. Problem number 37 on page 236 is an example that we're going to look at. We want to find the prime factorization of 1,440. Well, I'm going to utilize a tool called a factor tree. I start with the number 1440, and then I want to split it into a product of two numbers. Any two factors will do. So I'm going to take 144 times 10. You might think of some other different combinations, and that's fine. 10 is not prime. 10 is 2 times 5, and both of those are prime numbers, so that branch is finished. 144, I remember, is 12 times 12, but neither of those is prime. 12, 2 times 6, 6 is 2 times 3, or 3 times 4 is 12, and 4 is 2 times 2, and it's okay that the order's different. It doesn't really make any difference because the prime factorization will be unique. That is, there is one answer. Now, I want to give the prime factorization as a product, and I notice that all of my factors are 2s, 3s, and 5s. Count the number of 2 factors. 1, 2, 3, 4, 5. Now let me check that. 1, 2, 3, 4, 5. With an exponent of 5 here to indicate the number of factors. 3's, 1, 2, so I'll put an exponent of 2 here, and then there's one factor of 5. And now I have a prime factorization for the number 1,440. It's 2 to the 5th power times 3 squared times 5. One of the uses for prime factors is to find the greatest common factor and the least common multiple. On page 236, problems 45 and 57, we want to find the greatest common factor and the least common multiple of 42 and 56. First step, let's do a prime factorization. 42 is 6 times 7, 6 is 2 times 3, and all of those are prime. 56 is 8 times 7, 8 is 4 times 2, and 4 is 2 times 2, and now they're all prime. So I'm going to write 42 as 2 times 3 times 7, and 56 as 2 times 2 times 2 times 7, but I'm also going to write it with exponents, 2 to the 3rd power times 7. Now, the greatest common factor, what I want to do is match up as many factors as I can. And I notice I can pair up a 2 and I can pair up a 7. So the greatest common factor is 2 times 7, 14. Now what that means is that's the largest number that will divide evenly into both 42 and 56. To find the least common multiple, I look at the list of factors again. I have 2s, 3s, and 7s. So I'm going to write down those factors. To find that least common multiple, I take the highest exponent that's on each factor. I have a 2 to the 3rd power, but 3 and 7, the highest exponent is just 1. Now I want to multiply these numbers together. 2 to the 3rd power is 8 times 3 times 7, and when I multiply that out, I get 168, and that's our least common multiple. That is, it's the smallest number that both 42 and 56 divide evenly into.